here you've got this function right here that you guys said is odd. It's cubic, and its leading coefficient is negative. So its graph would take on some kind of a shape like this. Okay? So if I want to talk about end behaviors, I want to talk about it as x approaches positive infinity and as x approaches negative infinity, what's happening? Well, we had that chart yesterday on that core concept that said, well, it kind of tells us. But kids, as I'm moving for x going to positive infinity, that's like saying get on the graph and continue to move right. The further I move right, what's happening to this graph? Is it moving upwards or downwards? Downwards. So what's your y value going to approach then? Negative infinity. Good. And then what's the x value going to approach, or I'm sorry, what's the y value going to approach if x approaches negative infinity right here? In other words, I keep moving left on this. The further I move left, am I moving up or down? So is y approaching positive infinity or negative infinity? So the thing I pointed out yesterday was this. When you're dealing with odd functions, how about the end behavior for your y values? Are they the same or are they different? They're opposite of each other. Yesterday we talked about odd functions will have opposite end behaviors. Even functions will have the same end behavior. Okay? So let's jump into this graphing stuff here and see if we can't figure some things out here in example 4. Okay? Big word right here is this. What did I underline up there? Sketching. Okay, I'm not asking to be perfect. I'm asking to be pretty darn close here. Okay. So what we're going to do here, kids, is this. Anytime you're sketching graphs of polynomials, it's a great idea to make a table. Okay. So I'm going to make this table right here. All right. I'm going to put some x values in and some f of x values. I need your help here. I'm going to need some volunteers. So be ready to help out. Some x values I'm going to put in. I'm going to put from like, say -4 all the way up to maybe +4. I'm just going to go by 2's here to make a table. Okay. What I need here, kids, is some volunteers to plug these in. Now, yesterday we said when you plug these into your calculator, anytime you substitute a value in, always, always, always put what around that? Parentheses, okay? So I need a volunteer. Whoops, I forgot this. This should be -2 on this next one. -4, -2, 0, 2, 4. Who's going to volunteer to put -4 in everywhere where there's an x value up here for me? Who's I can? Jaden, you've got that one, okay? So everywhere there's an x, what are you going to put around the -4? Okay, who's willing to put -2 in for me? Jaden's got -4. Annika, you've got -2. I'll do 0. Okay, I can handle that one. Who's doing +2 for me? Sterling's got +2 and a volunteer for +4 for me. Gabriel, will you help me out with that? Okay. When you get a value, just raise your hand and let me know. I'm going to tell you when I plug 0 in, I get 2 out. Okay?
-42.
Negative how much?
42.
-42. Wowzers. I'll make sure -64 and 16 is -48. Negative.
You want me to do it again? I got 6 for -2. Yeah, I don't think mine's right. One second.
I'm not liking -42 very much there, Jaden.
Yeah.
I got 6 for 2.
Okay, so 2 is 6, 8. 8 is gone. Yep, I agree with 6. What did you get there, Annika, for -2?
6.
I agree. Who had 4 for me? Gabriel, did you have 4?
66.
I agree, 66. Jaden, did you come up with -30 the second time around?
I still got negative. Now
Did
I
you?
got negative.
Okay, I'm just going to tell you right here. -4 cubed is -64. Negative 4 squared is plus 16. So negative 4 plus 16 would put me at negative 48. Negative 4 is another plus 16, so that takes me down to negative 32. Add 2 more. I like negative 30, okay? I'm going to look at your calculator here in a little bit and make sure we're getting that in there correctly. Are you putting the minus sign in or the little negative sign in? Negative down there? Okay. Are you putting like all of negative 4 in parentheses and then the cube part is outside? Let me see that quickly, and now you've got me concerned. Because that's a great calculator. Negative 4 to the third, plus what was it? Negative 4 squared?
Minus 4x.
Just need to warm up. Feels very cold. Okay, so guys, here's the deal. We've created some points, and if you can kind of tell, what value did I kind of work around here for my inputs? 0. Now I could have put negative 3 and a negative 1. I decided I'm going to count by 2s. Okay. There's no rhyme or reason to the points that you put in, but here's the deal. We get these points. Now, kids, I'm going to try and graph this as best I can. First of all, kids, is this a cubic function or a quartic function? Is this function cubic or quartic?
Cubic.
Cubic. So it's going to be odd. So the end behaviors are going to be opposite of each other. We know that. Okay. So I'm going to blow this graph up here a little bit. Guys, the first point that we should plot would be negative 4 comma negative 30. Am I going to be able to get to negative 30 on my graph at all? No, negative 4 right here, down 30 is going to be way down here somewhere, isn't it? Way down here. I'm going to put a little arrow down here. It's down there somewhere, okay? However, could I plot the next point at negative 2 comma negative 6? Is that a possibility? Is negative 2, negative 6 a possibility? So I'm going to go left 1, 2, and then down 1, 2, 3, 4, 5, 6. Okay, what's the next point we might plot?
Isn't it negative 2 positive 6?
Oh, yes, thank you. Yep, negative 2 positive 6. So I should go left 2, and instead of down 6, I should go up 6, right?
Why do the numbers upside down?
I don't know. Don't worry about it. Well, I'm going to go left 2 and up how much, kids? Okay. So left 2 and up 6. What's the next value? 0 comma what?
2.
0, 2. And then my next one, what do we get? 2 comma 6 again? Right 2 and up 6. Guys, is there any way I'm going to be able to plot 4 comma 66 on my graph? No, but my question to you kids is this. 4 comma 66 is going to be way up here somewhere. Can you guys kind of see this third degree function happening? We were way down here. We're going to come up and hit this point, come back down, and then go back up like so. So a good sketch might look like this. Good sketch might look like this. We knew we had points way down at the bottom that came up, hit this point right up here, kind of wrap around to here, and then back all the way up. Wow, that's a really good curve, Parson. Until I screwed it up there in the end. Oh, boy. So you're going to sketch a third degree a cubic function, maybe to come back down and hit these like so. This would be a sketch of that right there. Okay? And again, I'm not asking you to be perfect. I'm asking you to get some points in there and then just draw kind of a smooth curve to come up, hit those, and then back around like so. Why is my graph that shape, kids? Because it is a cubic function. Very good, Lexi. Very good. All right. Let's try another one. That would be a sketch. Again, am I asking you to be perfect on graphs?
No.
No. And again, where could I go to see that at least kind of get an idea of the shape if I had to sketch these points? I could go to decimals and I'll say, hey, does what I have, is that kind of similar to an exact graph in decimals, okay? So again, I'm asking you to plot how many points up here, kids? 5 of them, okay? Let's try this one right here, kids. What type of function do we have in this next example?
Wait, Carson.
Yeah.
How do you know what numbers to put in on the X side?
It doesn't make any difference, honestly. I'm going to work around 0 because most of the assignments are going to be centered around 0 for you. Okay. So I like to go by 2s. I like to put whole numbers in. So I like to go 4 left and 4 right. Now, most good math teachers would say start at -4, go -4, -3, -2, -1, 0, and put all of those in. We're going to try and shorten that up. I think we can get a decent graph with less points. Okay. So same game here, kids. I need help. And you all knew that. Guess what values for x I'm going to pick to plug in again?
-4, -2, 0, 2, 4.
-4, -2, 0, 2, 4. I need volunteers to help me again. I'll just tell you 0 is going to turn out to be -3.
I'll do 2.
Who's doing 2?
I'll do
Yep.
-4.
You've got what, Annika? -4. I've got a speaker for -4 and +2. Who's doing -2 for me? Somebody help me plug in -2. I'll do -2 up here, okay, in my noggin. Who's going to plug 4 in for me? Maddie, you've got that one. So which one am I responsible for? -2? Okay, Parson, don't embarrass yourself. Ooh, gosh, negatives are tough. -8 is -8. 0, 2, -1.
I don't know if this is right, but I got -199 for 4.
Well,
-4.
Let me think, okay?
Maddie, what would you do? 4. What'd you get?
Okay, punch this in for me. Punch in -256 plus 64 plus 32 plus 4 minus 3.
159.
Positive or negative?
-159.
Yeah, I like -159, Annika. Who was my 2 person?
Oh, me. Got -21.
I like that. -21. Very good. Who was my 4 person? Okay, let me run this quick in my head here. 4 is 256. -256 minus 64 is -320. -320 and 32 is 12. So -288. -292. What do you have?
-268.
-268.
Do you want me to write 2 and 2? I got this.
Maddie, type these numbers in for me. Go -256 minus 64 plus 32 minus 4 minus 3.
-295.
-295. Okay. Guys, what values are you going to be able to plot? Looks like -2 comma what for sure?
-2, -1.
Okay, so let's plot that. -2, left 2, down 1. What else can I plot? 0.
-3.
Anything else I'm going to be able to plot?
I mean, if you get close to
Okay, the -4, -159. Let's think about this. We're going to go left, 1, 2, 3, 4, and we're going to be down here, way down here somewhere, aren't we? You agree with that? Okay, and then the other one, right 4 and down 295, we're going to be way down here somewhere like this. So it looks like the end behaviors are both going to be going way to the what? Bottom. And that makes sense because don't you have an even function here? So shouldn't the end behaviors be the same? Would you agree with that? Okay, so maybe a sketch like this looks like the following. It comes up, it hits this point up here, comes down through this point, flattens around, and goes down like that again. Okay? I'm curious to see what this looks like in decimals, to see if we're even close. Do you understand the idea about end behaviors? Again, is this function odd or even? Is this function odd or even, kids? It's even. The highest degree is 4. It's even. So should end behaviors for an even function be the same or should they be opposite? They should be the same. Are both of my end behaviors the same? Are they both tending towards the same value of infinity? Meaning negative in this case. They are. Okay? I'm just curious to see what a graph looks like. Let me pop this up here quick. Will you guys read me the function that we're dealing with here in example 4b? What is it, kids? Negative. Is it negative x to the 4th, kids? Is that right? Negative x to the 4th. Okay, I'm listening.
Negative x to the 3rd.
Minus x to the 3rd. Okay.
Plus 2x.
Plus 2x squared.
Minus x.
Minus x.
Minus 3.
Minus 3. There's our graph, kids. Gosh, do we have something that looked kind of similar to that? Started way down, came up to here, kind of peaked out, flattened through that next point, and then headed back down towards infinity. Negative infinity, I mean. Does our shape resemble this right here? Okay. Again, am I asking you to be perfect, or am I asking you to get some points on there to sketch something right now? Okay. And again, the thing I want you to understand is look at your function. Is it odd or even? Okay, if the function's odd, your end behaviors are opposite each other. If your function is even, your end behaviors are the same. Good. All right, so let's check this out. What do we have next? Any questions about sketching graphs? What is my suggestion for values to plug in? What am I suggesting you plug in? Okay. And guys, when you get really big numbers right here that aren't going to fit the graph, this is kind of a giveaway that says, oh, that goes to negative infinity, because that's really big right off the bat, isn't it? And oh, this is probably also going where, kids? This negative 2, negative 5 probably indicates that the function's going to negative infinity. Okay? All right, last page, kids. Let's rock this here. Oh my gosh. They're going to do this to us. Sketching a graph. We have all these rules right here that we have to come up with. It says you have to sketch a graph such that f is what, kids?
Increasing when negative 2 is less than x minus less than 3.
Okay, so basically what this is meaning is the graph is increasing between negative 2 and what?
3.
It says f is decreasing when x is less than negative 2, and it's decreasing when x is greater than what?
3.
Okay, it says f of x is greater than
0.
when x is less than what?
Negative 4.
And x is between 0 and 5. Oh my gosh, we have a lot to do here. And then f of x is going to be less than 0 when x is less than negative 4, and when x
Less than
is
0.
between, I'm sorry, when x is, f of x is less than 0, so your y values are below 0 when x is between negative 4 and 0, and it's going to be between there when it's greater than 5. Oh my gosh. Okay. Want me to make this simple for you?
Yeah.
Okay, let's do this. Sketch a decent sized coordinate plane here so we can write some things in here. Okay, and then in fact, what I would do is do your best to have some equal spaces in here. So I'm just going to go 1, 2, 3, 4, 5, 6. I'm going to put about 8 in there, okay, to the right. And I want you to put in about 8 marks to the left. 1. Okay, we have to sketch a graph. And our graph has to satisfy how many conditions there, kids? How many conditions does our graph have to satisfy? 4 of them. Okay. Okay. What I'm going to do, kids, is this. The first one up there involves -2 and then positive what? -2 and what? Okay, I'm just going to draw a little dotted line right here at -2. So I'm going to say, okay. Whoops, I really screwed that up. Let me do it this way. Right here, I'm going to draw a dotted line at -2 through -2. And I'm going to draw a dotted line at what other value? Okay, I know, kids, that in between those 2 points, my graph is going to be what? It's going to be increasing. Okay, I know that my graph is going upwards somehow in that set right there. Okay. Next thing it tells me here is less than -2. So I'm going to write this right down here. When I'm less than -2 and I'm greater than +3, I know that my graph is going to be what? Decreasing, right? So when x is less than -2, when I'm less than -2, so when I'm to the left of -2, I know my graph is going to be decreasing. So I'm just going to write the word decreasing over here. Okay, I know in this interval my graph has to be doing what? Decreasing, okay? The next thing that I know, kids, is that between -2 and +3, between -2 and +3, in other words, between the dotted lines, my graph is what? It's increasing. So I'm just going to write the word increasing down here right now. And then beyond +3, x greater than 3, to the right of this, in this next interval, we know the graph is going to be doing what again, kids? Decreasing. Okay, now, we need to take into account some values here, and I'll do this in a different color.
So far, so we would know that it would be a 410, right?
Yep. And you know that because over here on the end and over here on the end, they're both decreasing, right? So it has to be an even function. That's an awesome observation, Jaden. Good job. Give yourself a pat on the back. Stuff like that, when it comes up in class, that makes me think awesome. Okay. I'm at bullet point number 3. What's it say about f of x?
Greater than 0 when x is less than -4 and 0 when x is between 0 and
Okay. So what we need to do here, kids, is we need to mark off f of x is bigger than 0. So this is saying f of x is positive when x is less than -4. So I'm going to go over here and put another line here. Okay, I'm going to go 1, 2, 3, 4 to the left. I'm going to put a dotted line right here at -4. I know that f of x, when we're less than -4, is a positive value. So I'm going to put my stuff over here. I'm going to say we've got positive values over here. In other words, the graph is graphed above the x-axis, okay? And it's also going to be positive above 0 and what, kids? It's between 0 and 5. So here's a 0, and here's 5. We're going to be positive in this area. So the graph is going to be above the x-axis and above there, okay? Ooh, I don't know if I like this graph very much. This is going to be a tough one. Let me make sure I've got that typed in there right. Give me a second. Sure. All right. Step 4 says f of x is less than 0 when x is between 4 and 0 and greater than 5. Okay, I gotta back up on that, Jaden. We may not be quartic on this, all right? We may not have that yet. Because decreasing means that as you move left, the graph is moving downwards, right? Okay, so here's the deal. We know that this graph is doing what, kids? Decreasing, but left of -4 here, it has to be what kind of a value? So the graph has to be up here and decreasing. So when I talk about increasing and decreasing, you always think about increasing, decreasing as you move to the left. Okay? So I could start way up here, and as I move left, it could start falling down. But could these values still be positive values here? Okay, they could. All right? Then between -4 and 0, the graph moves to be f of x less than 0, meaning in between the two black dotted lines, we've got negative values. So I'm just going to do this here quickly. No, we're going to have between -4, between -4 and 0, we're going to have negative values. Okay. We know that then from 0 to 5, again, up here, we're going to have positive values. And then beyond 5, x greater than 5, f of x is less than 0 again. So over here, we're going to have negative values again. Okay? So let's look at this here, kids. Look at the blue lines first. Everything over here on the left, is my graph increasing or decreasing in this first section? But my graphs have to be what type of values up here, kids? They have to be positive. So your graph could start out like this. And I'm going to put my graph in red right here. Could my graph start out like this and get to right here? Is that decreasing, kids? Is that graph decreasing as I move left to right?
Yes.
It is. So it can satisfy. Are these values greater than 0 left of this right here? In other words, is this graphed above the y-axis? The answer is what? Yes, it is. Okay, and I make sure I'm paying attention on this because this stuff, if you're not paying attention, you're not going to have a clue. Okay? All right? Now, it says it's decreasing all the way down to here, but now in this interval, my values are what, kids? Negative. So I have to go below the x-axis here. Now, kids, all of a sudden at this blue dotted line, my graph starts to do what again? Starts to increase here. I got to increase, but I've got to stay below what, kids? Okay, so this is going to kind of curve around to right here. At this point right here, my values go from negative to what? Positive. All right, so my graph's going to go up to positive values. And it might look like this. Is my graph increasing still? Okay. And what happens then after I'm done increasing up to the blue dotted line? It starts to do what? Decreasing. Now when I get to the black line, my positive values turn into what? So it's going to decrease down to what value here? 0. And then after this dotted line, my values are going to go to what kind of values again?
Negatives.
Oh my gosh. Okay, let's see if we've satisfied all these conditions here. let me ask a question. Between -2 and +3, the blue line's right here, is your graph increasing? We're good there. Less than -2, that's the blue dotted line. Less than -2, is this graph decreasing? Yep. And past 3, right of 3, are we decreasing? Past this blue dotted line. We're okay here, right? Is f of x positive left of -4? In other words, right here, are we positive left of -4? Yeah. Is my graph negative values down here? Are we below the x-axis between -4 and 0? Between 0 and 5 here, are we positive? Excuse me. Yeah. So we're okay here. And then is my graph negative between here and here, like it wants to be, and negative beyond here? I'd say we're okay. Oh my gosh. That might be the toughest problem we've seen all year. Okay. We have the decreasing part down, we have the increasing part here, and we have the decreasing part down here. Okay, we're positive up to the dotted line black. We're negative from here, -4 to 0. We go positive values again. We go negative values again. Okay? So down at the bottom, I think when you have to sketch these, decreasing, increasing, decreasing would be a good idea. And then up here, do intervals, is the graph positive values or negative values? All right? That is a tough, tough problem. Okay? Might want to star that. You might see something like that again. All right, last example here. Volunteer to read example 6 here. Let's put this stuff into play, and I'll get you going on a short, quick quiz today.
The estimated population P in thousands of people living in a city can be modeled by the polynomial function P t equals 1.2t to the third power minus 2t squared plus 15.7t plus 3.8, where t represents the year, with t equals 1 corresponding to 2001.
Okay. So part A says use a graphing calculator to graph the function for the interval 1 up to what? 10. And it says describe the behavior of the graph on this interval. Okay, let's do that quickly. So would somebody be willing to read that function to me while I pull up Desmos here? First of all, is this going to be a cubic or quartic function? Okay, so let me pull this. All right, so go ahead. What is that function, kids?
1.2t to the third power minus,
I'm going to put in x. Is that okay?
yeah, minus 2x to the second power plus 15.7x plus 3.8.
3.8?
Yeah.
And it said, look at the, I think it said, look at the behavior between 1 and what, kids? 1 and 10. Okay, so I'm going to go into settings right here. Actually, I can kind of zoom out, I guess, between 1 and 10. I'm going to put in some values here. I'm going to change my settings. So I'm going to put my x values between 0 and 11. Because we want to look at 1 through 10, right? Okay, and then we put some values in here. So I'm going to put in, say, 1,000 and go by hundreds. Okay, that's what your graph looks like between 0 and 10 right here, kids. I've got kind of a chart right here. I changed some stuff to get some decent values here. But guys, from 1 up to 10 right here, looks like this graph, is this graph increasing or decreasing from 1 up to 10? It's increasing, isn't it? So what I want to do here in part A, they ask the question, it says, describe the behavior of the graph on this interval. It looks like it is either increasing or decreasing. What would you say? Graph is increasing, okay? On the interval, graph is increasing for 1 less than or equal to t less than or equal to 10. Okay? And again, I picked some values in there to get a good read on this here, and I'm not sure I want enough. Okay. It says, what's the average rate of change? What's this mean right here, kids? Again, we've talked about this a lot. Average rate of change simply means find the slope. Okay, it says from time 2001 to what? 2010. Okay, I can use my graph to do this. Okay, you're going to have to help me here. I need your help. Down here on my graph at 1 comma something, when I plug in exactly 1, what's the value there?
18.7.
Somebody remember 18.7 for me, okay? All right, and then I'm going to go over here to x equal 10. Looks like I need to pull the graph down here a little bit. Who's going to remember this number when I get to exactly 10? Oh, I had it.
1160.8.
1160.8, right? Okay, so you got 1160.8. What this is really doing, average rate of change means find the slope. Well, guys, what was the point? 1 comma, was it 18.7? For 2001, that's like 2001, that's the first year. What was 2010? 10 comma what?
1160.8.
Okay, you guys go ahead and find the slope there. You would do y2 minus y1 over x2 minus x1. 1142.1 divide 9.
Wait, how do you find it?
Y2 minus y1 over x2 minus x1. That minus that over that minus that. Anybody have a slope yet?
One second.
Guys, slope again. 1160.8 minus 18.7 over what minus what? Right?
So, negative.
Ooh, should be positive. Wasn't our graph increasing? Okay, so should be positive, right?
Oh, wait, hold on.
Got it, Maddie?
Is it 126?
I love that. Slope is 126.9. So the average rate of change is 126.9. It would be people per Okay, now guys, do you think that this model can be used for years before 2001 or after 2010? Explain the reason. First of all, kids, my graph looked like it was doing what when we had this? It looks like it's increasing. And does it look like it's going to increase and stop at a certain value, get to a certain value, or does it look like it's going to increase for a long, long time? Do you think that our population is going to get close to infinity? I mean, infinity is as big as you can get. Is this going to be a good model or a bad model if we're talking about population approaching infinity? What do you think? I mean, doesn't there come a point of equilibrium when there's so many people that are fighting for resources and stuff like that? What's that cause? When people start fighting for resources, what does that cause? Yeah, war. Okay? Is our population ever going to go towards infinity? Or is it going to stall out somewhere? Yeah, so is this a good model or not? Probably not. Okay, no, because eventually, at some point, because in real life, given resources, population growth will eventually stop. I mean, you look at things like, well, Hurricane Michael, kids. If you were part of Hurricane Michael and had no resources, you've seen the people on the news before. When a food truck or the water truck comes in, are people just like, oh, I'll be nice and let that person have that water and let that person have that water? Or are they fighting to get that stuff?
Fighting.
Yeah, it's like Black Friday at Walmart. They open the doors and everybody's fighting over the 10 TVs they're selling for 20 bucks, right? And then that makes national news. So, yeah, I mean, there comes a point in time where resources, there's not enough for a certain population. And populations get mad at each other, and what do they start doing?
Fighting.
Fighting over it, which ultimately leads to, unfortunately, death. Okay? All right. A lot of good stuff in here. This is tough stuff. I hope you're paying attention today, because if not,
Wait, Preston, could you stay there?
I can stay right here. All right, I am going to hand out a short, quick quiz here. You may or may not get done with it. Plan on time to work tomorrow. I have good news. The graph on this one here, the numbers didn't flip around. I don't know why those numbers flipped around like that. That was weird. Sorry.
I thought I was reading it wrong. I was like,
There you go. Guys, if you have to sketch a graph of something, what x values do I want you to use on your table? Jane, do you have what you need up here?
Yep.